So the last video we set the groundwork for the first couple of steps of hypothesis testing. Remember to get really comfortable with these steps as we're going to do them in several different contexts. Right now we're working on the context of testing a research question about one proportion. So the example we were working on, we had the research question, is there evidence that more than 11% of adults watch Stranger Things? And our hypotheses we stated, HA, or the alternative, had our research question, is P, the population proportion, greater than 11%? HO is our initial assumption, is that the proportion is in fact just 11%. Our second step was to actually go ahead and collect our data or our evidence and compare that with our initial assumption. So we had our formula here for that comparison. We assumed we had 10 people out of a sample of 30 that watched Stranger Things. So our test statistic was just converting that to a z-score under the assumption of HO, the null hypothesis. So our observation, or the evidence we have, is our 33%. We're comparing that to the initial assumption that 11% watched the show, and we were very careful that the standard error also had the null hypothesis down here and not p hat. When we worked this out, we got a z-score of nearly 4. Based on your experience with z-scores, you should know this is a really big value. Z-score of 4 is way beyond most of the bell curve, so the chances of having data this far off, an observation this far away from our assumption of 11% should be pretty small. So that's exactly what we're going to do on our next step, is quantify this distance in terms of a probability. So here at the bottom, we've got our step 3, calculating the p-value. And I cannot emphasize enough here, when we're talking about p-values, this is a probability. Your answers must be between 0 and 1, since we're talking about probabilities. How we find this also depends on our research question. So we had 3 different variations for our research question. Let's take a look at each of those variations. The first one, HA, is less than. So that's what we had. In our example, we actually had more than 11%, but we could have asked the question, what if it's less than 11%? So we have a z-score that we just calculated. That's our test statistic. So I'm going to draw a bell curve here. That's standard normal with 0 in the middle. And maybe I have my test statistic somewhere over here. I'm just making up a spot, it doesn't matter. The p-value tells me what's the probability of getting this test statistic, of seeing this kind of evidence or data, that discrepancy between HO and my data, or more extreme. And the or more extreme depends on HA. So in this case, HA is less than, so the or more extreme is going to be everything less than my test statistic. We know how to find this. We've been working up to this point. If I know a z-score, I want to find the probability below that. Easy. Let's check out normal CDF. And my lower on this one should just be negative infinity. So put in your favorite big negative number here for negative infinity up to my test statistic. So that's my p-value. Again, p means probability, is the chances of seeing my data in terms of the z-score, or more extreme, and the or more extreme is defined by HA. So I'm shading less than because that's what my HA is. All right, I've got other options for HA. Another option is like what we just did in our example. HA might be greater than. So I'm going to draw the same picture here. I've got my normal curve. Here's my test. Here's 0 in the middle. My test statistic measuring how far the data is from the null hypothesis. Maybe it's over here. Just a quick side note, that test statistic could be a negative number. There's no need to freak out about that. Could be positive, could be negative. I'm just making it positive arbitrarily. HA is greater than, so I want to find the probability of seeing my data, or more extreme, and the or more extreme part means greater than or above my test statistic. Again, we know how to find that on our calculator, normal CDF. And please humor me for a while and draw these pictures when you're working on your problem. So normal CDF, our test statistic, out to your favorite big number for positive infinity. All right, we had one last option for our research question, and that was HA is not equal to. And we're going to start off with kind of that same picture. Here's my bell curve. Here's my test statistic, Z-calc. And the not equal to means, well, I want to consider the chances of my data being that far off either in the positive direction or in the negative direction. So I'm going to look at the negative version of my test statistic. I'm just going to put my absolute values here to be correct, so above the positive version or below the negative version. And that's why this was called a two-sided test in our first video. I'm looking at two tails or two options here. So I could find this two different ways on my calculator. I could find normal CDF, and I could check out that lower tail, so negative infinity up to the negative version of my test statistic. Okay, so that's this area down here. But I need to have both sides. Since this is symmetric, these two sides have exactly the same area. So let me just find that one and then double it. Multiply by 2 for two-sided. So when you see not equal to, find one tail and then double it. Multiply by 2. Or I could also do this another way. I could find the area of the upper tail and double that. So I could do normal CDF, and the upper tail would be checking out the positive version of the test statistic out to infinity, so this area, and then just doubling it to get both sides. Either one doesn't matter. Draw your picture to make sure you're doing the right thing here or there, and it's easy to make mistakes on this, so draw pictures. And remember, P is for probability. These are probabilities, so your answers need to be between 0 and 1. Let's check out our particular example. Again, draw the picture to make sure we're not missing anything here. So there's our normal curve. Here's 0. We know that our test statistic we got, draw all this to scale so you make sure your answer makes sense, was 3.9089. Now technically this curve goes on forever in both directions. That's why we put plus or minus infinity. And if you remember, our HA, our research question, had a greater than sign in it. We wanted to see if more than 11% of people watched this show. So we're looking at this itty bitty area up here above a z-score of about 4. So we know when we calculate this, should be really, really tiny number. So let's do it. Our p-value is going to be our normal CDF. We're going to go from our test statistic, that 3.9089, out to infinity. Again, because HA is greater than, I'm shading above my test statistic. That's my or more extreme part. And if you do that, you might see your answer in scientific notation. It just means move the decimal to the left 5 spots. You get 0.000046. Okay, so tiny, tiny chances that we see our data this far away if the percentage really is 11, if 11% of people watch this show. So that's what we're going to do in our next step, is actually just interpret that percentage we found. Interpreting the p-value, I would highlight this interpretation. You're basically going to use this in your whatever the context of the problem is. So this is telling us this is how we found the p-value. If the null is true, that's what we assumed when we calculated this test statistic. We plugged in 11% everywhere. So if the null is true, we're going to see our data. So we put our data in that test statistic, or more extreme, we shaded more extreme according to HA, the above part, this percentage of the time. So notice this is just a regular decimal to make it a percentage. You need to do p-value and multiply by 100 to make it a percent. So in context of our problem, the null being true, maybe flip back a few pages for context. The null being true means the proportion who watch the show is 11%. So jot that down here. If 11% watch this show, okay, so again, that's our null hypothesis being true. Put that in context. That was p equals 0.11. That was our null. We would see data like ours. That's our test statistic. Or more extreme, that's the part we shaded. And then our p-value, we need to turn that into a percent. So take the number we found, multiply by 100 to make it a percent. So 0.0046% of the time. I want to emphasize here on this page, we just interpreted this in terms of the null hypothesis. Emphasize that in your notes. If the null's true, these are our chances of seeing the data. So hopefully you're thinking, if it's 11%, we're rarely going to see our kind of data. So that gives us evidence it's probably not 11% because our data would be such an anomaly according to this under that initial assumption. So our last step here is just to put that in context. So let's emphasize our step 5 here. And it always is going back full circle. So I'm going to say HA out in the margin as a reminder. Our interpretation or our conclusion is always in terms of the null hypothesis. So under the null, if we have a low chance of seeing the data, then the null is probably not true and we have good evidence for our research claim, and vice versa. I would really make a big deal out of this section. It's going to help you for the rest of the semester in your interpretation. So our conclusion is always in terms of HA, our research claim, and we're saying what kind of evidence we have for HA. Notice the pattern here is the p-value gets smaller, or the data gets less and less likely under the null hypothesis. You have stronger and stronger evidence for the alternative hypothesis or your research claim. So to finish off this video, our particular p-value was in this category. It was really small. It was less than 1% of the time. So our conclusion is going to be we have really strong evidence for our alternative hypothesis, but put that in context. So I'll say there is very strong evidence okay, again, very strong because we had such a teeny p-value, such a small chance of seeing our data under the null. So we have really strong evidence for our research question, which was that more than 11% watched this show. So there's very strong evidence that more than 11% watch this show. And I'm going to underline that here as a reminder. This, especially also the more than part is important. That's our HA in context. All right, I know that was a lot of steps. Last video, we're going to go through another complete example, kind of putting all these steps together.